Good morning, my students. Welcome to a new day. Let's quickly go through the last module of our class, Chemistry 451, Chemical Process Technology. And the last module is Module 6. I hope you've been enjoying the lectures all this while. Today is the 29th of September 2023, and I remain Professor Engineer J.T. Igwe. We're going to look at introduction, design of agitation tank, a basic stir tank design, scaling up criteria, and we'll look at conclusion. What we're looking at is a design of agitation tank. We're not going to go into the proper design. You're not in engineering, we're doing industrial chemistry, but it's good that we know some of these parameters that are important for design purposes. So the dimensions of a liquid content of vessel and the dimensions and arrangement of impellers, baffles, and other internals are factors that influence any part energy required for achieving a needed amount of agitation. So the design of the system, all the parts, baffles, impellers, the vessel itself, determines the quality or the production quality of that mixer. So before one starts using any mixer, there must be a design. What volume can that mixer control? What quantity do you want to mix? At what speed? What type of system are you mixing? Is it a high viscosity liquid? Is it going to liquid mixtures, gas to liquid dispersions, or solid particle suspension, and so on? The internal arrangement depends on the objectives of the operation, and these objectives are to maintain homogeneity of a reacting mixture. So you want to obtain a homogeneous mixture after the mixing process. To keep a solid suspended or a gas dispersed. In terms of reactions, you might want to allow the solid to be suspended, because if the solid is not suspended, then the reaction will not, proper reaction will not take place, or gas dispersed. To enhance heat or mass transfer. Remember our heat and mass transfer. We want to transfer heat from one phase to the other. These are some of the objectives of the operation. So the first one to look at is the vessel itself, the container. A dished bottom requires less power than a flat one. So you see what we're trying to look at. So a dished bottom requires less power than a flat one. And of course, if you look at a flat one, there is every possibility that, depending on the clearance of the impeller, if you don't have very good clearance, then the impeller, while rotating, the agitators can be scratching the bottom of the vessel, and that will not give a good mixing process. So sometimes we can use a single impeller, and of course, when we use a single impeller, the liquid level, we have to also know the optimum level of the liquid and know where to locate the impeller, whether it's at the center. We'll see reasons at the center or off center for any system we want to use. Baffles. Except for high Reynolds number, baffles are needed to prevent vortexing and rotating of the liquid mass as a whole. Now remember when I told you about a bucket of water, and I said baffles resembles when you put your hand, you are rotating the water already. If you put your two hands by the sides of the bucket, you will see that your hand by the sides of the bucket will stop the rotation or disturb the rotation and make the mixing, better. I know that in the case of what I'm describing, what we want to do is a kind of a centrifuge. I know some of us have done that. If you take a bucket of water that is, having some suspended particles, when you do that rotation after some time, all the particles will go down. And and then you can just decant, that is collect the upper layer and use it. Most likely you want to take your bath and you see a lot of suspended particles and you don't have any other option, nowhere to get any other water. So what baffles are like when you take two, measuring ruler, put by the sides of the bucket. So those ruler you put there will disturb the full rotation of the liquid, and by so doing, it makes the mixing faster and better. So let's quickly look at the baffle. A baffle width 1/12 the tank diameter, you see. So tank diameter divided by 12, that is the width of the baffle. A length extending from 1/2 the impeller diameter from the tangent line bottom to the liquid level. These are the dimensions that are acceptable or are better for you to achieve a better mix. When solids are present or when a heat transfer jacket is used, the baffles are offset from the wall a distance equal to 1/6 the baffle width. So these are dimension calculations. 4 radial baffles at equal spacing are standard. So you see 4 that is at equal spacing, one opposite the other this side, one opposite the other this side, is what we say standard. 6 only slightly more effective. Sometimes you have 6, and 3 appreciably less so. So it depends on what you want to do. You might want to have 3 baffles, 6 baffles, 4 baffles, but we'll say 4 is standard. When the mixer shaft is located off center, so you see sometimes you can have off center, that is 1/4 to 1/2 the tank radius. So it's not every time that the shaft is located at the center of the vessel. Sometimes it is located off center. The resulting flow pattern has less swell and baffles may not be needed. So remember our swelling, axial swelling, tangential motion of these fluids. So when that happens, you may not even need baffles because the mixing will be very, very good. Now, draft tubes. A draft tube is a cylindrical housing around and slightly larger in diameter than the impeller. We will see the diagram and see all these things. Its height may be little more than diameter of the impeller. Usually, draft tubes are used with axial impellers to direct suction and discharge streams. An impeller draft tube system behaves as an axial flow pump of somewhat low efficiency. Its top to bottom behavior is of particular value in deep tanks for suspension of solids and for dispersion of gases. Impeller tubes, impeller size, impeller speed, impeller location. These are things we are trying to, for instance, impeller types classified into axial and radial circulation. So we have axial impellers, we have radial impellers, and then impeller size will depend on the Reynolds, Froude, and Weber number, and even the power number. Now, for the popular turbine impeller, the ratio of diameters of impeller and vessel falls in the range d/dt. That is the ratio of the diameters of impeller, which is small d, and that of the vessel, capital D subscript small t, falls in the range 0.3 to 0.6. These are calculations that needs to be done. Now, impeller speed, look at the speed. I don't know, some of you were around when we were producing hand sanitizers during the COVID period. We used things like this. At the end of the day, we used manual, and then we later had to go for construction. So we did all these calculations and decided the kind of vessel we want to use, the kind of agitator, the kind of impeller, draft tubes, and then the person who was to do the construction was called. We also had a speed control with commercial available motors and speed reducer. Standard speeds are 3745. Look at that. Now, but sometimes you just have 2 speed drives when you're starting the torques, when starting torques are high. So sometimes you can reduce because there's a speed you use and you cause more vortex. Remember that as the vortex increases, there's likelihood of your liquid spilling. So we'll try to check the speed. So we'll have speed regulators or speed motors that we can use to control the speed. Then impeller location. we have said that we'll put the impeller at 1/6 the liquid level of the bottom. There's also for different bottom suspension, side entering impellers, dispersion of gases, we use different types of impeller locations. Now, design of agitation tank. So these are the parameters. You have to decide on the type and geometry of the tank, like we said, and the agitator you want to use. Find the performance of the installation first, the rotating speed, the size, the power, then you scale up to commercial scale. And these are relevant parameters: impeller diameter, impeller speed, shaft power, brake power, tank diameter, and so on. And even the viscosity, density, surface tension of the liquid is also very important. Now look at the tank. We just decided to put this here. You just pause this video and look at all these things we are talking about, and look at the relationship, look at the height, look at the clearance, height over 6, look at what we call baffles. This is a baffle, this is another baffle here. Because of the 2 dimension, you're seeing the one by the side. There should be another baffle at the back here, and then another one in the front here if you're using 4. Now look at our impeller diameter, look at the tank diameter, capital DT. So all these things, baffle width W is equal to DT over 12. The offset is W over 16. Look at our draft tube. So all these things we've decided to put here so for you to see. You see, volume of the liquid circulated by impeller must be sufficient to sweep out entire vessel in reasonable time. In mixing, also it needs turbulence, which results from properly directed currents and large velocity gradients in liquid. So these are the very important things you need to note. Circulation and generation turbulence both consume energy. So large impeller plus medium speed is equal to good flow. That's nominal flow. Then small impeller with high speed will give you turbulence. Now, like we said, once you're able to do your design, then you scale up. And this scale up will now depend on so many things we have listed here. The Reynolds number, Froude number, Weber number. You check the power consumption, the tip speed, all these things you use. Then which scaling up process you use depends on the practical situation. Remember, we said that most times these things are not standard. You have to determine the liquid you want to agitate, the kind of mixture you want, the viscosity and all that. Then you decide the kind of scale up you want to do to industrial scale. Look at the introduction, design of agitation tank, a basic stir tank design, scaling up criteria, and discussion. And this brings us to the end of this lecture. There are other classes, but for 451, this is the end of our class. Thank you so much for keeping faith with this class, and I hope you enjoyed all the lectures. Thank you and God bless you.